This is ACT Math Manual Section 14. Section 14 deals with translation. So in this section, you are going to need to know a few different languages, possibly Korean. Just kidding, we're not talking about those kinds of translations. Section 14 deals with mathematical translations, which basically involve questions that have words and phrases that can be directly translated into an algebraic expression or equation. So example 1 is a good place to start to show you what a translation might look like. You might want to do this on your own. If so, pause the video. So as we read this statement from left to right, there are certain parts of the statement, certain phrases, certain words, you can see them marked with brackets, that can be translated into an algebraic expression or equation. So the square of t is, how many is an unknown, so I'll put an x, times, and then the sum of a and b. The sum of a and b looks like that. So this is t squared equals x times a plus b. That is what we mean by translations. We mean taking a worded statement and putting that worded statement into an algebraic expression or equation. Now, in this chart labeled translation chart, we have most, if not all, of the translatable words and phrases that you may see. Those are in the left-hand column of the chart. So these would be your tip-off clues. Oops, that was supposed to be an eyeball. There we go. These are your tip-off clues, and then over here on the right is what you would actually write down. This is the international symbol for what you would write down, just so you know. So again, what you see on the left and then what you would translate to will be in the right-hand column. If you feel confident that you know most of these terms, most of these words and phrases, go ahead and fill in the right-hand column on your own. Press pause. I'm going to run through them right now. So first, if you see a number or what or an integer or, as we saw above, how many, that's going to be a variable, an x, an n, a y, an a b, whatever you want. Keep in mind that if the question already contains an x that has been defined as something else, for instance, if they say something like Maria has x dollars, and then they say how many in a later part of the question, you might not want to use x because you're going to get it confused with the number of dollars that Maria has. Now, is equal to, that one pretty self-explanatory for most students. That's an equal sign. More than, sum, increased by, again, pretty simple for most students. Less than, difference, decreased by, we've got minus. Of, times, product, that is multiplication. I'm going to put a little dot so I don't confuse it with the x. Per, or for every, or out of, that would be a fraction bar or the division symbol. I'll write both of those. Is greater than would be the greater than symbol. Is less than would be the less than symbol. The last four here are definitely the toughest for most students. These are the four that tend to stump students. I am just going to fill these in right now, and if you have trouble with these or you are not able to conceive of why these translate to what they translate to, you're going to have to ask your tutor or do a little bit more poking around on your own. Is no more than means less than or equal to. At least or no less than means greater than or equal to. The square of n is n squared, not to be confused with the square root of n, which is what I just wrote. So those are your major, pretty much all of the things that can be translated. Obviously, I'm sure there's other things that will show up that you will also need to translate, but again, these are the major ones. You need to make sure this chart is memorized. Most of these, as I said a couple times, are pretty self-explanatory. Some of the trickier ones down here towards the bottom, you're going to need to make sure you know very well. Next, page 106, we have 6 or 7 examples, 5 at the top and then a couple of problems at the bottom. I would, if I were you, run through at least 1 through 5 right now. If you're very confident with translation, you can just go ahead and run through all of them if you would like. So Karen or Corinne, I don't know how she likes to pronounce her name, so I'm going to say Karen. Karen has at least $10 more than Barry. This one's tough for some students. We start off with sort of a tough one. This would translate to Karen is greater than or equal to, is at least, Barry plus 10. Karen has, the has would sort of translate to the, well, actually this entire phrase, has at least, would translate to the greater than or equal to. The more than would be 10. Karen, I'm throwing in a C. Barry, I'm throwing in a B. So again, Karen, C, greater than or equal to Barry, B, plus 10. That's how that would translate. Example 2 also can be tricky. A number, I'll do this one phrase or word at a time, 6 less than twice Z. So a number, I'll call that N, is, now this less than phrase, keep in mind that less than, this is the first note, less than and is less than, those are two different phrases. Less than, if you don't see an is before it, or you see something like this where it is and then there's a number, so is number less than, versus just a solid is less than. This translates to the less than sign, like N is less than 10. Okay, but is 6 less than, or is 5 less than, is number less than, that translates to subtraction. So that's the first note to keep in mind, that whenever we see less than, we can't immediately think of the less than symbol. It very well might be subtraction that we're dealing with, not an inequality. Now the other thing is that this less than, this is 6 less than, this is the one of the only cases in translation where we have to actually flip the order of the terms that we see. A lot of students make the careless mistake of writing N equals, a number is, N equals 6 less than twice Z. A lot of students do 6 minus 2Z. This is not correct. This is a careless mistake. You need to make sure you don't make that. 6 less than 2Z would actually be 2Z minus 6. 6 less than 2Z is 2Z, take away 6. So yeah, number 2 can be slightly tricky for some students. Number 3, Andy has 5 times as many stamps as Brian. The has, so Andy would be A, the has, the 5 times, obviously that's going to be 5 times, and then Brian. So that has is just going to translate to an equal sign here. So this is Andy is 5 times whatever Brian is. So Andy is 5 times Brian. Andy equals 5B. Whatever the number of stamps Brian has, Andy is equal to 5. This is a 5, by the way, not an S. Andy is equal to 5 times Brian's number. So A equals 5B. That's what example 3 translates to. Next, we have number 4, which actually tends to be fairly self-explanatory as long as you don't make a careless mistake with your zeros. So the number 0.004 is 1,000 times what number? So 0.004 equals 1,000 N. And then this number 5, some students get a little bit confused about what to do with the what fraction. So we've got 7.5, the is, the what fraction, the of, and the 35. So 7.5 is, I'm going to leave this blank for 1 second. We know this is going to be of 35. Remember that what fraction is almost exactly the same as just an unknown. So we don't need to do anything fancy here. We don't need to put in a numerator or a denominator or anything. We can just do n. And remember that when we solve this, I'm actually going to go ahead and solve this. We would divide both sides by 35. So we would get n equals 7.5 over 35, which actually would clean up to 15 over 70. So, and then that would actually reduce. I'm not going to reduce it right now. So notice that when we solve this, we do get a fraction for n. So there's no need to worry about accounting for this word fraction when we're actually translating. What we get out of the equation will be the fraction, and we can just call that fraction n. So no need to get too fancy there. Hopefully those weren't too bad for most of you. Let's take a look at number 5. If you haven't already done it, you might want to pause and do this on your own. I'm going to go ahead and do it right now. A company rents moving vans for a rental fee of $25 per day with an additional charge of $0.3 or 30 cents per mile that the van is driven. Which of the following represents the cost in dollars, so I shouldn't have said cents before, of renting a van for 1 day and driving it M miles? Okay, so cost of renting for 1 day and driving M miles. So what a lot of students do here is one of a couple things. One is they go immediately to the answer choices and start looking at them and maybe doing a little bit of a process of elimination. Other students might think about what the translation is and then go to the answers. Remember, from the keys, which you learned way back in section 3, you always have to write your work, and you always have to get to your answer before going to ACT's answer. Remember, you be proactive. You go after the answer. Do not let ACT bring the answer to you. So I'm going to pretend that I don't even see these answer choices here, and I'm going to translate this. So the rental fee is $25 per day, and we're doing it for 1 day. So we know that we've got that $25 charge already. And then it's 30 cents or $0.3 per mile that the van is driven. So if I drive M miles, I will be paying a total mileage fee of 0.3 times the number of miles that I drive. 0.3 times M. If M is 1, I'm just paying that 30 cents. If M is 2, I'm paying the 60 cents. If M is 3, I'm paying the 90 cents, and so on. So my overall translation here, my overall expression will be 0.3 M plus 25. That is what they were asking me, and now I can go to the answers and I am done. So 0.3 M plus 25. Again, get to your answer before looking at their answers. Number 27, definitely the hardest of all of these. By the way, back on number 5, notice you do have variables in your answers. So for those of you who might struggle on a question like this, hopefully too many of you did not struggle, but if you are struggling on a question like number 5, you could throw in a value for M. You could say, well, I'm going to drive 5 miles, and then the fee would be the $25 for the day. If you drive 5 miles at this $0.3 per mile, that would be an additional $1.50 that you would pay, so you'd be paying a total of $26.50, and indeed answer choice A would come out to be $26.50. None of the other ones would. So you could do a question like that using VITA if you needed to. My recommendation would be to know how to do this using the algebraic translation, however, because it is a little bit more efficient. 27. Take a stab at it on your own if you haven't already. A hot air balloon 70 meters above the ground is falling at a constant rate of 6 meters per second, while another hot air balloon 10 meters above the ground is rising at a constant rate of 15 meters per second to the nearest tenth of a second. After how many seconds will the two balloons be the same height? So how many seconds to be the same height? Now, this question stumps a lot of students, and it's understandable. It's definitely a little bit of a trickier translation. I will say you can use nidus on a question like this, and I'll give you a little preview of how that might work. So for instance, in answer choice C, if the number of seconds is 2.9, well, this first hot air balloon, I'll call this one at 70 meters. This guy will be A, and the one at 10 meters, this will be B. So A will be at 70, and remember, it's falling at 6 meters per second. Well, if we go 2.9 seconds, we're going to fall 6 times 2.9. So this will end up being, and I'm going to do this right in the calculator, 70 minus 6 times 2.9, and I get 52.6. So that balloon is at 52.6 meters, and then balloon B at 10 meters and rising at 15 per second, and we're going 2.9 seconds. So I would do 10 plus 15 times 2.9. I'm going to put that in parentheses just to be safe. 15 times 2.9. And look what I get. I get 53.5. Now, some students do look at the 53.5 and the 52.6 and they say, okay, so those aren't equal. And the question was saying, when the balloons are going to be at the same height. 52.6 and 53.5, these two numbers are not the same height. However, remember, these have been rounded to the nearest, these answer choices have been rounded to the nearest tenth of a second. So this 2.9 is an approximation, which means these two are not exact numbers, which means answer choice C is probably the correct answer. These are pretty damn close. And you notice if we jump up to 6.7 or down to 0.4, we're going to get something way different. I mean, these answer choices are pretty far off from 2.9. Obviously, you could go ahead and try answer choices B and D to see what you get, but C by the Nydus seems pretty good. Now, we're in the translation section of the manual, so we should do this with translation, and we should find that it's not too difficult. So let me move this out of the way so that we're going to have a little bit more room. So the translation would look like this. So remember, the height of A can be translated into 70 meters, take away 6 meters per second. And I'll use an S for the seconds. That's what we did actually down here in the Nydus. And that has to be equal to B's height, which can be translated into 10 meters plus 15 meters per second. 15 meters per second would be 15 times the number of seconds, in the same way that 6 meters per second, to get the total number of meters fallen, we would multiply the rate by the number of seconds. By the way, I know that per might confuse some students. They sometimes wonder why we're multiplying here when there's a per in the question. Well, remember, think of it this way, 6 meters per second. If we want to get the number of meters out of this rate, what we have to do is we have to multiply by the number of seconds that we travel. So some number of seconds, let's say like 2 seconds, and then what will happen is the seconds will cancel and we will end up with the unit that we need. So just a little bit of background as to why we are multiplying here when we see a per. The per is simply part of this term right here. Basically, this term 6 is a 6 meters, and there is a 1 second in the denominator. 6 meters per, there's where the per is, the division, 1 second, and then we multiply by the number of seconds to cancel the unit seconds and be left with meters. Anyway, just making sure everybody understands why we are multiplying here and why there's no division, even though we see a per, the word per. Now, this is just a basic algebraic equation. We just start cleaning up. So I'm going to subtract the 10, subtract the 10. I get 60 over here. These guys go away. I'm going to add the 6s to both sides, 6s. So I get 60 equals 21s. 15 plus 6 is 21. I divide by 21, divide by 21. I go in my calculator and I find out that 60 divided by 21 should be 2.9, which is what we got by Nydusing. So 60 divided by 21, there it is. So 2.857 to 2.857. And that's what I had mentioned before, that there is a little bit of a rounding issue going on here. That's why we didn't get an exact match down here. So 2.857 would round to 2.9, and indeed the answer is C. So that is basically it for translation. Number 27 will represent, a medium or even hard version of translation. You'll see some that are slightly harder than that and a bunch that are much easier. If you memorize this chart and you were comfortable with these examples, you shouldn't have too much trouble with translation questions on the ACT. That is all for section 14.